Hey grade 10s. So today we're going to talk about cell size and how it relates to the health of a cell. And that connects to what we talked about last lesson in regards to transport, because basically how easily something can transport in and out of a cell will depend on the health of the actual cell. So if diffusion across the cell membrane or within the cell is actually too slow, the cell won't get what it needs fast enough. It'll be inefficient and it could die. Well, we don't want that. We want our cells to keep living. That would be great. Okay. So how can diffusion rate of a substance in and out of the cells be increased? Okay. So we want things to be able to travel into and out of the cell easily at a nice speed. So a couple quick ones, I'm not going to talk about in crazy detail. Concentration gradient, so the difference between how high or low that concentration is of the substance, and then that will affect our diffusion speed and that process. Cell size, we're going to talk about in detail, so that's a huge impact on the health of the cell and deals with your surface area and volume ratio. The size and number of pores in a membrane. So basically, the more there are, the better substances will actually be able to travel across. Okay, and temperature. We know, okay, at different temperatures, things can speed up or slow down. Okay, so in regards to cell size and how big or how small a cell is, for a cell to survive, it must have a high surface area to volume ratio. So this is key. So I would write this down right here. Okay. And you should be able to do a little quick calculation. It's not any crazy hard math. So surface area divided by the volume of the cell. So you want whatever number you to get here when you do a calculation to be quite big. So if you're to look at this example I have over here, you have a 1 millimeter cube, a 2 millimeter cube, and a 4 millimeter cube. So sometimes we think the bigger the cube, the better it has a chance to survive. Interestingly enough, if you look at your calculations here, so surface area, there's 6 sides, calculate the area of each side. Surface area is 6 on this one. Volume's 1. So the surface area divided by the volume is actually 6 divided by 1, so it's 6. Now, if we were to look at the 2 millimeter cube, the surface area is 24 millimeters squared. The volume's 8, so 24 divided by 8. This is a 3. And then if you look at the 4 millimeter cube, 96 for surface area divided by 64. And this is actually 1.5 calculation for surface area divided by volume. So your little 1 millimeter cube is actually the highest surface area to volume ratio. So if the surface area to volume ratio is too small, basically what happens is the membrane surface is not big enough for substances to enter and leave. With the high surface area, okay, so basically more area exposed. So this is essentially what you want. You want a high surface area and you want a low volume. Okay. So, and this is what gives you your ratio that you want for a healthy cell. High surface area basically means you have a large outer area that substances can come in contact with. So whatever food or substances that need to enter in can, and whatever waste or excretion that needs to leave can leave. Where the low volume, this is the key part, less volume means that there's actually less distance for nutrients and waste to travel. And less distance to travel means faster it can go in and out. Okay, so this would be something I would write down, be a high surface area to volume ratio. Okay, and it's actually better to be a small cell. Okay, and that is the general gist of that one. So this is why, okay, multi-celled organisms actually have a lot of tiny, tiny small cells instead of one big, ginormous cell, because by having some small cells, they can actually allow their cells to be healthy, because that small volume and large surface area, hence a small surface area to volume ratio, or a high surface area to volume ratio. And that is honestly all there is it for cell size. If you wanted to do a quick, another little calculation or a little reminder, you calculate area of a cube by going length times width, okay, times height. And for surface area, oh, sorry, that's volume, guys. Sorry, my bad. Okay, volume, length times width times height. And area, surface area, we're dealing with the area of the sides, so length times width and how many sides there are, which in a cube is 6. So if you had to calculate this out, let's say a cube that is 5 millimeters, I would do this. I'd go volume is 5 times 5 times 5, and surface area is 5 times 5 times the 6 sides. 5 times 5 times 5 is 125. And 5 times 5 times 6 is 150. So surface area divided by volume, we're going 150 divided by 125, and that is 6. So that's the little math behind it if you missed it out on the last example. Okay, that's it, guys. Healthy cell size is key. Smaller cell size is better in order for a cell not to die. Have a good rest of your day.